We're going to start working on a chapter about exponents, and so this should be a lot of review for you. Hopefully this will be an easy chapter for you. So if we look up here, we have, what does x to the fourth mean? Just remember, what does an exponent mean? That exponent, that little guy up there, it means that you're going to take that base number, that x, and you're going to multiply it times itself that many times. So I should see 4 x's here because it's x to the fourth. And so what we're going to do is we're going to look at 7 different properties. Hopefully, again, this is review, so you should be ready for these properties. Just be careful you don't get confused, because it's pretty easy to get confused on these. So here I have x to the fourth and x to the third. X to the fourth means I have 4 x's. X to the third means I have 3 x's. And so really it's all multiplication anyway, and so together I have x to the seventh, which means what happens is when you multiply the bases, you add the exponents. So 4 plus 3 is 7. Our second property is when you have an exponent raised to another exponent. So what this means is my base is x squared, and I'm going to do that 3 times. So I have x squared times x squared times x squared. And then if I add them, I have x to the sixth. And the shortcut to that is just saying you have 3 groups of 2. So we have 1, 2, 3 groups of 2. So really we're just multiplying, since that's what groups of means. Property 3 happens when inside the parentheses, and this is really important, inside the parentheses we have multiplication. And that's really important. If it's addition, this does not work. Again, if this is addition, it does not work. It has to be multiplication inside. And so when we have that exponent up there, what can happen? Because it's multiplying inside, we can actually just distribute that 2 to both of them. So this would be x squared, y squared. And then if we go over on the right, we're going to distribute that 3. But when we distribute the 3 to the 2, remember, when I raise an exponent to another exponent, I multiply. So this is going to be x to the sixth, y to the third. Oops. All right, so let's see here. Now we're on property 4. It looks like property 4 is about division. So remember, when you multiply bases, you add exponents. When you divide bases, so we have 5 of these up here, and we have 3 of these down here. So when you're dividing, remember, these guys can all cancel out. So basically I'm canceling out 3 of the x's. I'm left with 2 of them. And so we get x squared. So basically the idea is when you divide your bases, you subtract your exponents. So on this next example, we actually have 2 things. We have the multiplication on top, so that's going to be x to the seventh over x to the sixth. And then we have the dividing, and so I can take one of my x's, or sorry, I can cancel 6 of the x's on top and bottom, and so I'm left with just 1 of the x's. So the 5th property is, let's look at the difference here. Here I have x to the 5th on top and x to the 2nd on bottom. And I'm wondering, that's why I have a question mark there, I'm wondering if that can be the same as x to the 5th still, but instead of x squared on the bottom, I put it on top with a negative exponent. So let's just check that out. Remember when we talked about dividing exponents, I subtracted the bases. So I'm going to take that 5 minus the 2, and I get 3. And when you multiply the bases, we add the exponents. So 5 plus negative 2 is 3. And so the idea here is, if you have an exponent on the bottom, you can move it up to the top, but then the exponent has to be negative. Or vice versa. If you have a negative exponent, you can move it to the bottom of a fraction. So make a fraction, move it to the bottom, and now it's a positive exponent. And then that goes in other directions too. If you had a positive exponent on top and you wanted to move it to the bottom for some reason, well then now the exponent, now the exponent is going to be negative. So we'll have x to the negative 5th. All right, so that's property 5, moving exponents makes it negative. All right, property 6, what is x to the 0? So if we look here on this first one, I have x to the 3rd over x to the 3rd, and hopefully we all know that when you divide something by itself, it equals 1. But let's look at it another way. If I have x to the 3rd and x to the 3rd, remember we can subtract the exponents. So top exponent minus bottom exponent gives me that, and 3 minus 3 is 0. So over here it equaled 1, over here it equaled x to the 0, and so I'd like to conclude that x to the 0 is the same thing as saying 1. So whenever you have x to the 0, you have an answer of 1, which is a really simple, nice simplification. And property 7, our last property for today, is if you have a division or a fraction, same thing, and you have an exponent, you can apply that exponent to both of them. So now we have x cubed over y cubed. So as a quick overview, now it's time to actually use these properties in simplifying exponents. So if we just do this real quick, we have base to an exponent to another exponent, so we need to multiply those exponents so we get 3 to the 8th. And then I would like you to actually plug that in the calculator and tell me what that is worked out. But use a calculator. Remember, on a calculator you have 3 buttons. It might be a button that looks like a tent, so you would hit 3 and then that button and the 8. It also might be a button that has x to the y, or it might be y to the x. But either way, one of these buttons should work to give you your exponent. All right, then we have over here 5 cubed and 8 cubed. I know 125 on top. I'm not quite sure on bottom what the 8 is. But that would be your answer with them to the exponent actually figured out. All right, let's see here. So on this one, yes, I see I have a negative exponent, but first I see that I have the same base. And so we're multiplying the same base, so we should add our exponents. So this would be negative 2, and then negative 3 plus 9 is 6. So then we have negative 2 to the 6th power, which would be 64, I think. And it's going to be a positive 64 because I'm going to have 6 negative 2's. So I'll have a negative 2, that cancels out to a positive, and that'll keep on happening and it'll cancel out to a positive because I have an even number of negatives. All right, on the next one, let's see here. These are not the same bases, so I can't do anything with the exponents together. But because I have a division, I can actually apply that 3 to both of them. So I'm going to have a to the 6th, because remember we're raising an exponent to another exponent. And I'm going to have b to the negative 9th. But I don't want to leave it that way. Typically, if you have a negative exponent, you want to make it positive. So I'm going to move that b up. So a is already on top, and then b is now also going to be on top with a positive 9. All right, this looks a little bit crazy. So I have a bunch of same bases. But I also have a negative here. So when I have that 5, I'm actually going to look at it as distributing that 5 to the negative. So when you have negative to the 5th, that gives you an odd number of negatives, so it's still going to be negative. So I'm just going to put a negative out front. And then I have y to the 2nd to the 5th, so I multiply those, that's y to the 10th. I still have y to the 2nd and y to the negative 12th. And then now I can, it's all the same base, and so I can add my exponents. So we have negative y to the 0, because 10 plus 2 is 12, minus 12 is 0. And then y to the 0, anything to the 0 is 1, so I'm going to have negative 1. I still have that negative from before. All right, my last two problems. So we have r and then s squared. Notice that squared is just for the s. The r is just a 1. That exponent is just a 1. But over here on the bottom, that 3 is going to have to go to both of them. So I still have r and then s squared over, and then I'll have r cubed s to the negative 3rd. And then it's time to put these things together. Here I have r to the 1st over r to the 3rd, which gives me r to the, well, let's subtract. 1 minus 3 is negative 2. And then on this one, I have s to the 2nd over s to the negative 3rd. So it's going to be 2 minus negative 3. Be very careful with these negatives. You can easily mess that up. So it's actually going to be s to the 5th. And that will be my answer. Now for this last problem, I have a squared b and a to the negative 1 and b to the 5th. And so again, I need to subtract my exponents since I'm dividing. Be careful with the a's though, because it's going to be 2 minus a negative 1, which will be plus 1. So it'll be a to the 3rd. And then for the b's, it'll be 1 minus 5, so it'll be b to the negative 4th. But I don't want to leave that negative, so I need to move that b to the 4th down. A to the 3rd is still up on top, and then it'll be b to the 4th on bottom. And I believe I forgot to do that with the r and the s, right? Because that r can't stay up on top because there's a negative exponent. So it's going to be s to the 5th over r to the 2nd. And that will actually be the answer. So we want to try and stay away from the negative exponents.